Pleasure to be here with you today. I'm going to talk about Java 8. In fact, I'm a little shocked. And the reason is, I was one of those guys on the other side of the picket line constantly saying that Java sucks. And for me to be here to sing the praises of Java is definitely surprising for myself. But I think Java deserves every bit of that. I started looking at Java 8 about 18 months or so ago. And I was just drawn into it. I was just amazed at what this language can do with the new additions of language. So I want to share some of those with you today. And best time to ask question or comment is when you have it. If you have a question, do speak up and draw my attention. I'm blinded, I cannot see over there. But just raise your voice, draw my attention. I'll be more than happy to listen to your questions. So this is the next big thing in Java. Let's think about where we came from. When was the last time something really exciting happened in Java? The first was when anonymous inner classes was introduced way back in Java 1.1, way back. Then Java 5 had some very questionable features, generics and autoboxing. We can debate about it. What about Java 6 had no language features at all? Java 7 had one feature that I love the most. You could put underscore in numbers. Because as I'm getting older, that's a feature I really like a lot. So I'm being facetious here, absolutely nothing really exciting happened in Java. All that is about to change, some real good excitement. So what is that? Well, that's basically Lambda Expressions. So Java 8 now has Lambda Expressions. So what is a Lambda Expression? Well, it's an anonymous function. Well, okay, it's more than an anonymous function. It's a cute little anonymous function. What does it really mean, having an anonymous function? So I'm going to start with something absolutely familiar. We have done this a million times in our programming career so far. I'm going to start with something absolutely familiar, and I'm going to redo this about 5 or 6 times over. Always doing something we know, changing just a little bit to learn something and then improve on it. So let's get started. Let's say for a minute we want to start with a list of numbers. Keep it extremely simple. So I have a list of integers here. We'll call it numbers for a minute. And this numbers is going to be, let's say, arrays.asList. And all I have here is just these little numbers to begin with, right? And I want to go ahead and print out all these numbers. So what would I do? For int I equal to 0, I less than numbers dot size or length? Size, okay. Size, and wait. Is it less than or equal to? You know where I'm going, right? Have you enjoyed off by 1 errors? Yeah, how does it feel when you do that, right? So that was quite a bit of work. It worked, but if you want pattern, there's a pattern name for this. It's called self-inflicted wound pattern. There is no reason for us to do this. This is 2014, come on, right? So we have done this for a very long time. Now, why do I not like this? Well, people will look at this and say, oh, that's simple code. No, they got the words mixed up. The word they're looking for is not simple. The word they're looking for is familiar. And there's a big difference between the word familiar and the word simple. Familiar is something that we have seen several times over, kind of like the mother-in-law, right? She's familiar, but doesn't mean anything. So the word simple means something that makes you get your work done, something that doesn't hurt you, something that doesn't make you scratch your head and say, was it plus or minus? Was it less than or equal to? So Michael Feathers once said that object-oriented programming is to encapsulate the moving parts. Functional programming is to eliminate the moving parts. What a great way to think about this. If you look at this code I wrote right there, that one single line of code is treacherous. It's got so many moving parts in it. There are at least 3 ways to get this wrong. And we don't want that kind of code. Well, fortunately, we can do a lot better than that already in Java. So we could go back to this code and say for, and then we could say element. And in this case, we could say numbers. And then we can simply output just the element. Notice how it produced the same result as the other code, but it had fewer moving parts in it. So this is definitely better. And we have been able to do this for a very long time. However, both of these code examples are exactly one thing, and those are called as external iterator. So what are external iterators? External iterators are where you have to tell it several times not only what to do but how to do it. This is like having a rude dog at home. You say move, it doesn't move. You got to keep pushing it every step of the way, right? But on the other hand, instead of an external iterator, we're going to use what's called an internal iterator. So what is an internal iterator? Well, an internal iterator is like throwing a frisbee and the dog jumps to go get it. So the point really is you say what to do and the underlying library decides how to actually accomplish the task. So let's see how we're going to use an internal iterator to get the same job done one more time. So this time I'm going to say numbers.for each. Stop right there. We already made an enormous difference. Well, you say, hey, wait a minute, you're calling a method on a function, on an object. We have done this before, haven't we? Sure. But look at the difference between the top code and this code already. The top code is a for loop of two different flavors. In the bottom one, we are calling a method on the collection. What does that really mean? Well, one thing we are also fond of in object-oriented programming, polymorphism. So in other words, all of a sudden, we went from a static code which only does one thing, which is loop through this using the sequential iteration, to something very polymorphic. Look at the line on line number 18. We have a code that says, just tell me what to do, but I will decide how to do it. Whether I should do this sequentially, whether I should do it lazily, whether I should do it in parallel, that is not your business right now. We can move that polymorphically. At runtime, I can figure it out based on other settings. We'll see how that helps later on towards the end of this presentation. But for now, keep in mind, this is polymorphic. But how would I use this? Well, the for each method wants to say, I'll accept a consumer. So new consumer, I'm going to start with a consumer object. Now, what in the world is a consumer? So I'm going to go ahead and import consumer, which is in Java 8. I'm going to say function.consumer over here. So now that I brought in the consumer, I'm interested in using the consumer. So I'm going to say over here, accept. And the accept method says, take in a value and output the value. So notice the code produces exactly the same result as the previous versions did. So we use the for each method. Now I mentioned this is better because this is internal iteration. This will take away the burden of iteration from you. It decides how to iterate. It could be now, it could be lazy, it could be parallel. It's got polymorphism. It's got a wealth of benefits. This is definitely better. And you're thinking, okay, that is all good, but if I have to, for getting that niceness, if I have to use anonymous inner classes, heck no. Anybody here who gets up in the morning and gets excited saying, I'm going to use anonymous classes today, right? Not a single person, right? I can't see anybody who raised their hand yet. No, we all, in fact, you fall back on the bed and say, not again. I don't want to use that stupid code again, right? So we feel that way. Well, fortunately, we don't have to. So rather than having to do that, we could simply go back to this code, and this time around, I'm going to take what is familiar again, numbers.for each, and I'm going to simply say integer value, and then specify right here an output of the value right over there. So what did I just do? I replaced the call with the anonymous inner class with just an anonymous function. So we used the Lambda expression in its place, so you can see how sweet that is, a lot less code to write. This anonymous function we wrote, the Lambda expression, stands in for that interface, and we're able to pass that function. We nailed it down to the essence. Rather than dancing around and creating anonymous inner classes, we simply said, here you go, that's a function I want to implement, that's a function I want to execute per iteration. You take care of how you want to iterate over this, but that's the essence I want to provide for you. Now, there is still one problem in this code. If you look at this code for a second, notice how you said integer value. Now notice, what is numbers? We know that numbers is a list of integer. So what in the world other than integer could this be? And you kind of sit there and say, integer value, and Java is like, thanks. But we are talking about the obvious back and forth. So for the very first time ever, Java is finally intelligent. So we could simply say numbers.for each, and just say value and output the value you're interested in. So we could just say value. So notice that this code produces exactly the same result. We didn't have to say the obvious. So the value is integer. But why the ceremony of parentheses when you have just a single parameter? So we could say value, and then you want to output the value right there, so you can see that that worked as well. Excuse me. Well, okay, so far so good. But this leads to one other problem we have to deal with. Notice this code for a second. What in the world is that code doing? It receives a parameter value and turns around and sends that value off to the system.out.println. Now, is there any intelligence in that code at all? Absolutely nothing. About the 7th time you write that code, you're going to get tired of writing that code. That's a noise. I have a nice pattern name for that code. I call that code the Office Space pattern. Remember the Office Space movie? In the Office Space movie, the guy says, Tom, what do you do here in this company? I take the requirements from the business people and I give it to the programmers. Right? That's what this is doing, right? It's just getting a parameter and handing it off. Now, as a Java programmer, you will get tired writing that code, and you would say, that's stupid. But we have one thing we know for sure in history. Java programmers never, ever write stupid code. They invent IDEs to vomit that stupid code. So they kind of knew this was coming, right? So they said, let's fix this right away. And so they gave us something beyond Lambda expressions. It is called method references. So we simply say system.out:\println and ask it to forward route the parameter automatically. Method references can do some really nice job of routing parameters pretty well, depending on the context. So what did we just do? We started with something extremely familiar, something that we have done a million times over, which is not really simple. It takes a lot of effort, easy to get wrong, and also very static. It only does sequential. We refactored it a few times over, and we got it down to something that's a lot concise, a lot simpler, very elegant, easier to write, very expressive, not error-prone, and easier to parallelize as well. So you can see how we took what we have done before. We didn't do anything different before than we did before, but we wrote it in a lot more elegant manner than we used to. And that's where the power of Lambda expressions and the features in Java 8 come to us. So this is a fundamental shift in what we are doing. We go from an imperative style of programming to a functional style of programming. So rather than saying how and when and exactly what to do, we say what to do and leave the libraries decide how to actually do that. That's what we are seeing in this example. So in order to understand this, let's go a step further. This eliminates mutability quite a bit. That's one of the best things of functional style of programming. So what does it mean by eliminating mutability? Well, in order to understand this, let's take another example to play with this real quick and see how it eliminates mutability for a second. Now, let's say for a minute, I want to take a value, collection of these values, and I want to double these values, let's say. So how would I double these values? Well, I would say in total equal to 0. And I want to print the total of the values doubled. But along the way, I would say for int element in numbers, and then I would say total plus equals element times 2. So notice how it doubled the value. Anybody who has written code like this before? Of course, all of us, right? You're just not willing to raise your hand for that. I wouldn't either. Yeah, absolutely. Now, how do you feel when you write that code? Dirty, right? You go home, if the kids come running towards you, say, don't touch me, I got to go shower first, right? That's how you feel after having done this work all day. And it's even worse. Those of us who work from home, if the kid runs into the room, you have to close it right away. Otherwise, the kid looks at it and says, that's what you do for a living, right? And they don't want to take up after a profession afterwards, right? That's just really bane. Let's fix that. So what am I going to do here? Well, I'm going to say over here, let's say numbers.stream. Hey, what in the world is that stream? Well, a stream is a fancy iterator in Java 8. A stream is an iterator. Well, we know what iterator is. It gives us has, next, and more, or next. Well, this guy is a little bit more powerful. He gives us various flavors of iterators: for each, map, filter, reduce, all the wonderful methods. So we go to the stream, and we're going to say map. And we're going to say, given a value, I want to return a value times 2. And then I can call either a method called reduce, and I can say start with the value of 0, and I want to take a carryover and element, and I want to return from here a carryover plus an element. So I'm providing a way to total these operations and ask it to execute that code, and you can see how that evaluated that code quite well. Now, what is the beauty of this? The beauty of this is, if you show this code to somebody and say, what does this code do? They scratch their head. They want to look at this and say, what does it really do? Here, the code is reading what the problem is. Given numbers, double each of the numbers and reduce it to a value. You could go a step further. You could call a method called sum, which is more expressive than this code. But unfortunately, you cannot quite easily do that. And the reason is sum is available on integers, doubles, but not on people and chairs and books and stuff like that. So you got to help Java just a little bit to say map to int and then sum, and Java is willing to work with you at that point. So you can see how you wrote a very expressive code, but there is a big difference. The big difference is the top code is imperative in nature. So there are two smells of imperative code. The first smell is you have to tell it not only what to do, but how to do it. First, create this variable, initialize the value, then start iterating, then get the first element, then the next element, then double it, then total it, then save it. A very low level. So that feels like you are working with a 2-year-old. Honey, just get up slowly, walk slowly, hold with both hands, please. The bottom one is declarative. You said what to do. This is like speaking to an adult. Well, actually speaking to a responsible adult, let's say. So that feels like more natural. Could I have a cup of water, please? And the person knows what to do. So that's declarative in nature compared to imperative in style. The other thing is, the smell of imperative is mutability. Notice how we created this total, but we constantly modified the total over and over and over. If you turn up the volume of the computer right now while you run this code, on line number 10, the variable total is going to keep saying, ouch, 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 because you're constantly changing it. Whereas in the bottom code, there is no mutability at all. Well, what's good about not having mutability? A code that has mutability is very difficult to parallelize. A code that has no mutability is easy to make concurrent. So that is one of the biggest benefits we see in this approach as well. So we saw the benefits of imperative versus the declarative style. But how does this really help? It helps to provide the methods into these classes. But how in the world did they provide this method called for each or stream in these classes? Where did they come from? Now, we know one problem. We cannot quickly modify interfaces that exist, because if you modify an interface that exists, all the implementations would end up breaking. So to fix this problem, they were trying to find out a way to escape from this little limitation, and they found there is a way to do this, which is called default methods. A default method is a method which can be added to an interface. You can have a method implementation in an interface. So interfaces in Java 8 not only can have declaration of methods, they can also have method implementations, which are default methods, and they can also have static methods. And so because we can have these kinds of methods, it becomes a lot easier to work with these code. Now, how does this really help to write code with these methods? Well, default methods basically say, if you have an implementation of a method in your class, I will take it. If the method doesn't exist in the class, I will bring it from the interface. So by providing a method and an interface and marking it default, you are not forcing the derived class to implement it. But if the derived class doesn't implement it, picks it up from the interface, but it can override it if it wants to. Now, one problem you may think about is, hey, is there a problem we have to worry about? I was giving this talk in another city, and one lady had a wonderful way to ask the question. She took her hand and did this to me and kind of put her hand down. She kind of hinted, what about the diamond problem? Well, a diamond problem is multiple inheritance problem, meaning when you inherit from two classes, you have an implementation that collides, and that's one of the reasons why multiple inheritance is really frowned upon. Well, Java doesn't have multiple inheritance, but we can have multiple interfaces. But if interfaces now can have methods methods, default methods, are we in the same boat? Well, thankfully, no, because there are 4 rules that we have to use for default methods. Rule number 1, when an interface extends another interface, it can override a default method, and that method takes precedence on the interface than one in the base method. The second rule is, if you have a default method in a class hierarchy, remember Java can only extend from one class at a time. If a method is available in the class hierarchy, it takes the method from the class and ignores the default methods, so you don't have the diamond problem. If a method is not available in the class hierarchy, and if the method is available only in the interfaces, then it will complain that there's a collision, and you would have to implement that method in the derived class before you can make use of that. So there are some rules that are available to eliminate these kinds of problems of these diamond problem, and default methods give you a way to extend the interface. So the methods like stream and for each have been added into existing collections as default methods. But let's move on to talk about decomposing of these to create some really interesting effect. Let's go with this example one more time. I'm going to change the problem just a little bit more, and this time around I'm going to say that given this collection, let's actually even extend this a little bit more. So let's say that I have more values on my hand. I'm going to say find the total of the first even number greater than 3. So right there, I've got a little problem on my hand. I want to find the total of the first even number in this collection that is greater than 3. How can I do that? Well, let's write a simple, familiar code for it. So I'm going to say total equal to 0. I want to output the total when I'm done. It's 0 right now, but I'm going to write the code. So int element in numbers. And what am I going to do within this? If element is even and element is greater than 3, then total plus equal to e times 2. So there you go. I have found the total I've actually taken the double of the, sorry, not the total, but the double. So find the double of the, pardon me. So find the double, I'll call this result for making this correct. So I want the result to be printed here. Let's call this result. So what am I doing really? I say I set the result value to 0 to begin with. And I'm going to loop through. If an element is even, and if it's greater than 3, I want to say that result is going to be a double of the element. So, is that good? No, what do you want? A break. It's only a 50-minute session. Why do you need a break in between? Oh, break in the code. Absolutely, right? Yeah, break. So, now, are you happy with this? Did you notice that? We went from that's broken to, I don't know what's up with this now. That is an example of imperative code. It hurts you in places you never expect. This code is broken, but we don't know where it's broken. Until one day the tester walks in and says, hey, your code sucks. And you say, well, thanks, I know it. But can you tell me how it sucks today? Right? Because as programmers, that's what we always ask, right? What did you do today? Well, I'm not going to tell you what's broken in this code. We'll find out what's broken in this code, but not by looking at this code, but writing it in a better way. So let's go back to this example right away, and I'm going to rewrite this. And I'm going to say output, and what am I going to output? Numbers.stream, and what does the problem say? Well, I want to take a filter, and I'm going to take a value and say value is greater than 3. And I'm going to filter again and say, given a value, value is mod 2 is equal to 0. And I'm going to say, map this again for me. So given a value, give me a value times 2. And then I'm going to say, find first. So in other words, I've asked it to perform a series of transformations. Given a stream, filter and get only values greater than 3, then get me only even numbers, then double the values, and then find me the find first. Now, when I run this code, not only will we see the result, but we'll also see what's broken in the other code. So when I run this code, notice it revealed something to us that we didn't see before. It didn't give us an 8. It gave us an optional 8. And I'm sure most of you are saying now, oh, of course. Why? Because what if the input did not have any even numbers at all? What if the input did not have any number greater than 3 at all? That code above is broken. We have to handle it. And how do you handle it? Well, we start with integer result is equal to null. How do you feel about that? Right? Nobody here likes it. But the bottom one not only gave you the problem clearly, it didn't hide behind the bushes, and it told you what it is, but how do I get the value out of it? Well, you can get the value by calling another method on this, and I have to admit to you, this method is the most threatening method name I've seen in the JDK. It's most threatening. It gives me shivers because it's called or else, right? You are like threatening it, or else what will I do? Well, you can give another value for it. If it doesn't have it, what do you want to do? So you could probably give another value that may make sense, or give a nice output, a message, whatever you want to do. Alternately, you could also call a get method to get the value, which may throw an exception to the value doesn't exist. Or you can say or else and maybe send a value of 0, for example, in this case, whatever it is, but you're programming with intention and you're aware of what's going on. Let's leave it at this for a second. Okay, great so far. Let's get rid of this code for now. And now we have distilled it. Now the first thing we notice here is one big advantage. The solution begins to read like the problem statement. You say, given the collection of numbers, I want to get everything greater than 3 and only even numbers, and I want only values, double of the value and the first one. You say, okay, this is great, it's expressive, it's nice, it's beautiful, it's easy to read, it's easy to understand, easy to go make change in this, but there is one nagging problem. We went from one loop to what appears here as 3 or 4 loops. Who in the right mind would want to do 4 loops instead of doing 1 loop? So that wouldn't fly at all if that's what it did. Fortunately, that's not the case. This is much better than what we thought it is. To understand that, let's refactor this code just a little bit, and I'll come back and show you what that is in just a second. So let's go ahead and say over here, Boolean is even. And I'm going to say, given a number, I want to simply return number mod 2 equals 0. I'm going to write another function, in this case, a static method, Boolean is greater than 3. And I will again say number, and I'll simply return over here, number is greater than 3. One more method, we'll call it as int double it. And this takes a number as well, and I'll simply return number times 2. I don't need these functions, but I'm doing this to make life easy for what I'm going to show you. So in this case, I'm going to simply say sample is greater than 3. This one I'm going to replace with the method reference sample is even, as we saw. And then finally, I'm going to replace this with sample, and I'm going to say double it. So that is all I did, and you can see the result is still the same. But are we still dealing with 4 loops? Let's think about this for a second. If this was done naively, what's the consequence? I've got 10 elements in this collection, which means I would apply this 10 times. Keep a count. That will remove the first 3 elements, 7 more to go. I would apply the second line in here 7 times. That's a total of 17 operations. That will remove everything that's not even. That leaves 4 more values. 17 plus 4 is 21. My gosh, looks like we're doing 22 operations. That would not be good at all. Let's see what's going to happen here in just a second. Well, one thing that I forgot to mention about streams. Streams share a property that I've seen only among my children. They both are lazy to the bone. I go to my children and say, you guys are fighting. Have you done your homework? Yes, Daddy. How is it? Done really nicely. Can I take a look at it? Sure. They run away. An hour goes by. I ask my wife, have you seen the children? Did you ask for their homework? Yeah, I guess I did. Well, they're probably working on it, right? So the point is, that's when they start doing it. So in this code, as you see here, you say, hey, stream, yes. Filter, done. Filter again, done. Map, done. Find first, oh dear. Let me go find out what these things are. But not only is it lazy, it applies some really interesting operations. It does what's called fusing of operations. So when it is lazily looking at this code, it just collects those functions into a bigger function and evaluates it only once and not many, many times. So there's no multiple iteration, there is one iteration. But even better than that, There's not one iteration fully, but only as much as is necessary. The minute the find first says, I'm good, these guys wrap up and go home. They don't do the rest of the work. So let's see how that works with this example. So to understand this, I'm going to go back to this code, and I'm going to output double it with, and I'm going to specify the number. I'm going to go back to the is greater than and say over here, is greater than with, and I'm going to say what the number is. And then finally, I go back here and say output is even with and specify the number. Remember, I was mentioning it's going to evaluate all those values so many times. Let's see if that's really true in this case. So when I run this little example, notice what it just did. It evaluated is greater than 3 only for 1, 2, 3, and 4. And the minute it found 4, it handed off to the next guy and said, let me take a break here while you do your work. And that said, I'm going to find out if it's even. Hey, guess what? It's even. Hands it off to the next function. That does the double, hands it off to the find first. And the find first says, cool, that's all I wanted. And the rest of the guys are like, let's go home, right? So they don't really do any more work. So the word lazy in Java 8 is pronounced as efficient. So you can see how this is very efficient in what it does, very nicely done, as you can see. So that is one of the biggest benefits you see, is that streams are lazy, and that gives quite an interesting power to us. But in order to understand this even further, let's go one step forward, and I'm not going to rely on the internet connection here, so I'm going to mark away just a little bit for that reason, so that I don't have to be enduring some connectivity problems. But let's go ahead and start with a little example and see how this is going to work. So I'm going to start with just an example of tickers.symbols. So I'm asking for some symbol values. You will see this example when you go to my website. You can download it. On that, I actually have the real code to talk to the web service, so you can actually run this in real rather than marking out the response as I'm going to do here. But I got a bunch of stock symbols, about 20 stock symbols. And what I want to do is I want to go ahead and find out the highest stock price, which is less than $500. Now, why less than 500? Because every time I run the code without that restriction, Google always shows up. So I said I'll just put a restriction to eliminate that. So I'm going to say, give me a higher stock price, which is less than $500. So let's do this. So what am I going to do first? Well, I'm going to first of all say list of stock info. Well, what in the world is stock info? We'll call it stocks. So here is my stock info. Stock info is nothing but a POJO. It contains a ticker and a price, which are public final fields. I've got a constructor which initializes the object with those values. I've got a toString method which simply prints out those values. So nothing really interesting in this POJO. So get rid of that. So I got a list of stock symbols, new array list, and I've got an empty array list to begin with. Oh, of course, I forgot to mention, I'm going to write this in an imperative style to begin with. And I want your favor, keep a count of the number of lines of code I'm writing. So right there, I wrote one line of code. The next thing I'm going to do is for string symbol. And where is the symbol coming from? Tickers.symbols. And I'm going to say here, stocks.add. And I'm going to add to the stocks. What am I going to add? Stock util. Well, what's stock util? Let's take a look at the stock util class. The stock util has a getPrice method. I'm marking away a little delay for talking to the web service, and I'm going to call into Yahoo Finance and call the getPrice method. The getPrice method will go to the web and find the stock price, parse it, and give it back to us. And we know that it's not a good manners to show parsing code in public these days, so I won't go into the detail of that method, but I'll let you take a look at it when you download the code. So that's going to give us the price. So what am I going to do? Stock util.getPrice, and I'm going to call symbol on it. What does stock getPrice return? GetPrice is returning, notice, a stock info object. So that is what I have on my hand. So that's great. So I have all the stock information. The next step I'm going to perform here is create another list of stock info one more time. And I'll call it as stocks under 500 equals new array list one more time. And this time around, I'm going to say for stock info stock. And this comes from stocks itself. And what am I going to do this time? I'm going to say if stock util dot is price less than 500. Then I'm going to say, oh, pardon me, dot test, and I'm going to specify in here the object I'm interested in. Then I say stocks under 500 dot add the stock itself. Well, what am I doing in the is less than 500? That looks a little weird to our eyes, isn't it? If you look at is less than 500, it takes a price value as a parameter, but it returns in response a lambda expression itself. Now, that's interesting. Because we're dealing with functional style of programming, we not only can't pass objects to functions, we can pass functions to functions. Not only can we create objects within functions, we can create functions within functions. Not only can we return objects from functions, we can return functions from functions as well. So this goes full round. We can treat functions as first-class citizens and pass them around as we please. So in this function, I'm returning back a function. So think of this as an example of not giving a fish to somebody, but to teach them fishing. In other words, rather than giving a result for an input, you give them a function. They can take home that function and keep calling it with various values, and they can look at the computation for it. So we return a function back to this caller. So if I go back to this code, you can see in here, we got a list of all the stocks which are less than 500. The last step here is going to be stock info, high priced equals new stock info. And in this case, we're going to specify for the stock info that I have, a no name and 0.0 is the value that I'm going to put right away. Oh, we lost the connection there. Can you check, please? The evil forces are against us. Did I mess something here? I hope not. So what we're doing in this case is we're saying, I've got a list of symbols. I'm going to get us a list of stocks with prices. Now that I have a list of stocks with prices, I'm going to now go back and use this list of prices and ask for a list of stocks less than 500. Hey, I like that even better. Okay, so and then we say, given a list of all the stock prices less than 500, I am now going to find the highest stock price that's available to us, and that's what we are going to do as a next step. So what is the last step I'm going to perform in this case? Well, the last step I'm going to perform in this case is to find what the price value is. And in order to find the price value, I'm going to do one more looping. And the looping I'm going to perform in this case is to go back and say for, and I'll say, in this case again, a stock info, stock. And this comes from stocks under 500. And we're going to specify now, in this case, high priced equals stock util dot pick high from the high priced and the given stock itself. If you look at the pick high method, you can notice that now that's returning a stock info, whichever is bigger than bigger of the two stocks in terms of the price value. So that is good so far. That's what we have done in this case. And then finally, we will output and print the high priced. Well, it's good to know how much time this is going to take to understand that. Let's go back to this code and say long start equals system dot nano time. And let's also go back and recreate that on the very end before we print it. So I'm going to say end equals that. And then finally, we will say, let's go ahead and say time taken. And this time we will say, this is going to be end minus start divided by 1.0E9, and we will print the time. So I'm running this code to see what it is going to provide for us. Let's eliminate this error right here. This is going to be tickers, and that's what I want to work with. Well, while it's running, let's think about what we just did. We first went to Yahoo and get all the prices. Then we looped through one more time, second loop, and removed all the prices over 500. Then the third loop, we picked the high price. Now, this is imperative in style, sequential in nature. And how much time is this going to take? Well, I got 20 stock symbols. Assume it takes about a second, give or take. That's about 20 seconds. So that's reasonable to see how much time it took. Now, how can I improve that code? Well, how many lines of code do I have at this point? About 20, 25. All right, I'll take 25. So 25 lines of code. Hey, there's one way to improve it. We could take the 3 loops and make it into 1 loop. That would be better, right? Well, but is the code readable? Who cares about readability? We only write code, right? Yeah. So, yeah, we could merge it all into 1 loop. But let's see if we can do this declarative, shall we? So let's go back to this code for a minute. Let's quietly comment that out. And in the very end, I'm going to simply call one function. And the function is going to be find high priced, right? And what does this take? Tickers dot symbols dot stream. So I'm going to pass a stream to this function. Well, what is the stream? I'm going to go back and say stream dot stream. So I'm going to bring in the stream. Let's implement this little code and play with it. So public static void find high priced stream of what? Well, stream of string, right? Thank you. So we have these symbols on our hand. Now I'm going to say, well, I want to measure the time as well, isn't it? So let's go ahead and ask for the time. So I'm going to grab this line of code so we can measure the time. So this is going to be the long. And I'm also going to measure the start. So let's say this is the start. And one more detail, I want to print how much time this actually took. And right now it's not doing anything, so it shouldn't take any time to do nothing. So we can make sure that's true actually. And right there, 0. Now, I'm going to output right away. And what am I going to output? Let's see if we can do this. Symbols dot. I have the stock symbols on my hand, but I want all the prices for it. What function would I use for that? Thank you, map. You are absolutely right. So let's go ahead and say dot map. Stock util, and this is going to be get price, remember? Great. Now that we have all the stock prices, I only want those less than 500. What function would I do for that? That's exactly right, filter, awesome. So we have a filter on our hand, and this is going to be stock price is price greater than 500. And look at the beauty. This was returning a predicate. Remember, it was returning a function. And what does filter want? Filter wants a function. Hey, we're in a win situation here. He wants exactly what this guy returns, so just pass it down. Now we have to call one more function to get the high priced, but here's a small quiz for you. Salt is to pepper as map is to... What was that? Hey, I like this game we are playing. Absolutely. Salt is to pepper as map is to reduce. So we have reduce. And what am I starting with? Well, stock info, the empty to begin with, comma, stock util, and then it's going to be pick high I'm interested in calling. Well, these are method references. Let's fix that. And this is going to be a method reference as well. Let's fix that. So we did that part real quick, real easy. And that gives us the high priced. Before we run this code, let's ask ourselves, how many lines of code did we replace the 25 lines of code with? We replaced it with 1, 2, 3, and 4 lines instead of 25 lines, right? So yeah, that one big line, it doesn't have any semicolons in between, so we'll consider it one line. So we're going to run this code, and when we run this code, how much time it should take? About the same amount of time, right? Because this is still sequential in nature. And what about the stock price it gives us? Well, it should give us the same stock price. Just because you're writing better code, you don't get better stock prices, right? Unfortunately. So that's what it should give you, and there you go. It gave the same price at about the same time. So far, so good? So what is the benefit so far? Well, the benefit is we wrote a lot less code. It's more elegant. It's functional in nature. We didn't mutate any variables. Life is good because of that. Overall, we've written better quality code. It is easier to understand if you know the syntax. It's easier to maintain, easier to evolve. It's easier to come in and modify and say, I want to do other filtering. So overall, it's a really good thing. But is that all the benefit? Well, there's one other benefit. Remember the projects we have worked on in the past. You are marching along fine, and one fine morning, a few weeks before the release time, the tester runs in and says, oh, we got trouble. And you say, what's the trouble now? Well, the application is slow. You're like, what do you mean it's slow? Have you tried this with 1,000 values? Oh, all our little unit tests never tried that. And now you throw 1,000 values on it, and suddenly it is crawling. Has it ever happened? Yeah, how do you feel when that happens? You are struggling, what do I do? And right in the middle of the day, as you're trying to figure out how to fix this really quickly, one of your colleagues says, I've got a great idea. And you say, uh-oh, what do you have now? You know how we have multi-core processors? We could do multi-threading. And you remember this fond memory from your previous project. You took the colleague's advice, and you started implementing multiple thread. So you had to modify code. First a little, then a lot. And then once you finish changing the code, you notice two things. The code doesn't look like the code you wrote all these months. It looks like a monster in front of you. And it doesn't work. Remember that? And while you're trying to debug the code, you applied for the next job. That's called concurrency. Right? Yeah, you don't want to do that anymore. Right? You've been there, done that. No, sir, I don't want to do that again. Well, what if we don't have to do any of that? What if you say, you know what, that's interesting. We could do that, can't we? Notice I'm not touching anything right now, except I say parallel stream. That is all I did, right? Parallel stream. And now we got the result back in a lot less time. Because, remember I promised polymorphism. The methods we see down below, like map, filter, and reduce, are all polymorphic. In that method, we told what to do, but not how to do it. And how to do is kept up there as a master switch. We said, do that sequentially, you flip a switch, do that concurrently. So you control concurrency, it doesn't do it automatically, but you didn't have to change all the code to benefit from that. So that is, we got rewarded for our good behavior. And what is that? We did not mess up with mutability. We wrote code where these little functions are pure. They didn't modify any state. They took in our input, did their work, and gave a result. And we composed through those operations very nicely, and they gave us a result for it. So we did good, and we get payback in evolving the code, and we can change it. And from going from sequential to concurrent was just flipping that one switch from stream to parallel stream. And parallel libraries make use of nice fork join under the hood and give us a good result. So I've gone through quite a few things in the past 50 minutes. There's a lot more in Java 8. The power is really amazing. I'm going to say that Lambda expression is really the gateway drug. Streams are the real addiction. And once you get a taste of that stream, you're going to be there for a long haul. It's going to be real power, and it's going to be really fun to use this as well. We can not only write more expressive code, we can express our ideas much more quickly. We have fewer bugs to deal with. We can evolve the code much more easily. And honestly, if you ask me, it finally feels right to program Java. Thanks for your time.